We had a few gorgeous sunsets in central Pennsylvania last weekend, the result of just the right arrangement of sun, clouds, and moisture. Sometimes, however, the atmosphere has an accomplice in producing unusually colorful sunsets, and that was the case around this time 25 years ago, in the summer of 1991. The co-conspirator then was a volcano named Pinatubo. Now, Mount Pinatubo is part of a chain of volcanoes on the west side of the island of Luzon in the Philippines, about 50 miles northwest of the capital of Manila. In 1991, the U.S. had two military installations near Pinatubo, Clark Air Force Base about 10 miles to its east, and a naval air station around 25 miles to its south. And both provided weather data during the eruption. Prior to 1991, Pinatubo had been dormant for centuries, so dense jungle covered the mountain. That changed in April and May of that year as a series of increasingly stronger eruptions prompted scientists to install monitoring equipment in anticipation of an even bigger one. A series of large eruptions began on June 12th, throwing ash 15 miles high, a canopy easily seen on satellite imagery. The climactic explosions occurred in a 3-hour period on June 15th, sending debris 20 miles up and in the process blowing 800 feet off the top of the mountain, forming a cauldron-like feature called a caldera. Coincidentally, a weakening typhoon crossed Luzon during the eruption, and heavy rain mixed with volcanic ash, causing massive mud and debris flows that spread 10 miles from the summit. Now here's a remarkable and very rare satellite image from June 15th. The clouds from the storm dominate the picture. But if we close in, you can see the ash cloud marked with an A poking above the clouds. And within that ash cloud, the most explosive plume in the middle is marked here with a B, overshooting even the ash cloud itself. Weather equipment at the ground also registered the eruptions. Here's graphs of air pressure from both nearby military bases. Now, the approaching storm caused the general decrease in pressure on June the 14th. But look at those gyrations in pressure early on the 15th. Each big volcanic explosion produced a compression wave in the air that caused a quick jump in pressure. Now, the time resolution isn't very good here, so it kind of looks like a blob of black ink. But this is really extraordinary to see a volcanic eruption show up so vividly on a barometer. Volcanoes also inject lots of gases into the air, and Pinatubo had global effects because of the 20 million tons of sulfur dioxide it shot into the upper atmosphere, where it combined with water vapor to form a haze of tiny sulfuric acid droplets that slowly spread around the globe. This veil of aerosols reflected a little extra sunlight back to space, actually lowering global average surface temperatures about a degree in the year after the eruption. And it was that thin volcanic haze that also led to extra colorful twilights at many places worldwide in the months and even years following Pinatubo. Stay tuned, Ben is back with the extended forecast next.